You'll notice this bell work is a little bit different. So please make sure you put on the date. I anticipate I will mostly go in order with these, but in case I don't, let's put on the date of 2/5/24, or write it out if you want to put February 5th, whatever. And the directions say, assuming no stretch or compression. If you're talking about stretch or compression, which one of these variables are we talking about? Well, it's either A, H, or K. Yeah, we're talking about A. So if there's no stretch or compression, that means that A is equal to either +1 or -1, right? And as I look at my transformed graph here in B, this is f of x. This is my parent graph. Okay. And this is g of x. This is the transformed one. As you look at this transformed one, what is my A value then? Is it +1 or -1? And how do we know? Why is it positive? How do we know? Yeah, it's going up, right? Both ends of the parabola are going up. So A is equal to +1. H. H, does that mean I'm going from left to right or up and down? Left or right. So as I look at my transformed graph from my parent graph, did I move to the right or to the left in how many spaces?
3 units right.
We went 4 units right. So that is 1, 2, 3, 4 to there. So H is equal to 4, yes. And K, that's the kangaroo. Did I go up or down in how many places? 3 units up. 1, 2, 3. So K is equal to 3. So my vertex, what is my vertex here? 4, 3. I'm sorry, what did you say, Kane?
I said 4, 3.
Oh, okay. And make sure if you're talking about something as an ordered pair, if you put parentheses around it, everybody knows that's an ordered pair in a particular point. Larry, make sure you're joining us, please. Yes. I cannot hear you. Speak up. Where did I get H?
The vertex, you said.
Where did I get the vertex? The vertex is always H, K for the new transformed parabola. So my H was 4 and my K was 3. Okay?
About
H. How did I get that? H from the parent graph here was 1, 2, 3, 4 spaces to the right. So 4 spaces to the right. And then we went up 3 spaces. Okay? Hey, if you don't know, that's why you ask, right? I appreciate that. So transformations, that means writing them out formally. Do I have a transformation if A is equal to 1? No, because that is not a change from the parent graph. When H is equal to 4, that is a transformation. What kind of transformation? What's that key mathematical word we use? Translates 4 units in what direction? What? To the right. Yes, to the right. And my K value, which is 3, is that a transformation? Yes. And we say it translates 3 units up. Question, could we do an equation from this? With all this information, could we write an equation? Doesn't say that we have to, but I think we could. So I'm going to say y equals, my A value is +1. What would come next? If it's a quadratic. This is, we're going to write this in vertex form because we have the vertex. So parentheses, x. Now this x, I'm looking at my h value here. I have a positive 4.
Minus 4.
That's right. Ha ha opposite. So if that is a positive 4, it has to be minus 4 in my parentheses. Rowan, can you please get your head up? And what else do I need when we're talking about quadratics? This is not linear. It has to be what?
Non-linear.
Which means it is, if it's a quadratic, it is squared. Okay? And then finally, k is plus 3. So that's my equation, even though we didn't ask for it. Any questions about this bell work? Okay, hang on to this, put it to the side. Let's take out those notes. So, new packet, module 12B notes packet. This is third period. I do one of these for each class. That way I can know exactly where we stopped. And let's take a look at this. A bunch of reading here at the beginning, but it's important to understand what's going on, okay? All right. So the objective says students will solve quadratic equations by graphing, okay? That's what we're working on today. So I'm just going to read, and I want you guys to follow along as I'm reading. Andy, put the phone away, please. Everybody else who has a phone, put the phones away. All right. A quadratic equation can be written in standard form, excuse me, ax squared plus bx plus c equals 0, where a does not equal 0. Because the graphs of these quadratic functions have 0, 1, or 2 zeros. Now, I think that's a little bit confusing, but you can have 0, 1, or 2 zeros. There's other words we can use for zeros. They are the roots, x-intercepts, or solutions. Okay, roots, x-intercepts, or solutions. But I thought it was kind of confusing when they said 0, 1, or 2 zeros. The corresponding quadratic equations will then have 0, 1, or 2 solutions. You're like, huh? So let me break it down for you. Key concept. Here we have 3 different graphs. In the first one, it says we have 2 unique real solutions. I want you to put a box or a circle around 2, okay? And I want you to go ahead and circle where you think the roots are, okay? Hopefully you circled something like this. It's the intersection of your graph with the x-axis. That has not changed. Those are your roots, your zeros, your x-intercepts, your solutions. The second one says we only have 1 unique real solution, okay? And I want you to circle that one. So it kind of hits or kisses, however you want to call it. Are you feeling violent or are you feeling lovey? Hits or kisses the x-axis. Well, Valentine's Day is coming up. And then goes up in the same direction. We call this a double root. A double root. Because it still has to be a quadratic. Okay? So for example, if I look at this, and let's say I put the axis of symmetry here, this looks to be maybe like -2, 0. Okay? Because it is a double root, and we'll talk about this a little bit more again in a minute, we're talking about x minus whatever that root is. Well, if that root is -2, x minus a -2 changes it to a +2. And because it is a double root, it's going to be the same thing again as it hits or kisses and goes off. Okay? So it would be x plus 2 times x plus 2. And you're probably like, what? So we'll get to that in a little minute. Looking at the last one, this is no real solutions. And the key word here is real also. There are some imaginary ones. We'll find that out in a bit. No real solutions. So my graph does not cross the x-axis at all. It's either above it or it could be below it. Okay? We call this, you could also write it like this. This is called the null set. Okay, so you could write this if there's no solutions, or you could put no real solutions. And the key word is you have to put real, because there are solutions, but they're not real solutions. Okay? And you could also write out null set, but a 0 with a diagonal slash is a lot quicker. So let's talk more about this double root. When the vertex of the related quadratic function lies on the x-axis, when it just hits or kisses that x-axis and bounces off, it is called a double root, which means there are two roots of a quadratic equation that are the same number. Underline, circle, or something. They are the same number. Okay? So, if I was looking at this over here, the one that has two solutions, this would be like x minus -2, because my root looks to be like -2, so that would be subtracting the opposite. This one would be x minus 2. And I'm just showing you, but this would be then x plus 2 times x minus 2. So that's the difference between that one and the double root. The double root is always going to be the root that is the same twice. Okay? Any questions on anything that I've put here in this first part? Okay, let's go to example 1 then. Example 1, solve a quadratic equation with two roots. Says solve -x squared plus 4x plus 5 equals 0 by graphing. Well, guess what? We're not going to make you graph here. We're giving it to you. That saves a lot of time. Graph the related function. The x-intercepts of the graph appear to be at what two values? Could you circle them? Please circle the x-intercepts at this time. And as you circle those, what do they appear to be? -1 and 5. Yes, those are the x-intercepts. Therefore, the solutions of the graph, guess what, are going to be at, take a guess, educated guess, -1 and 5. Yes, who's buried in Grant's tomb? Probably Mr. and Mrs. Grant. All right, any question about example 1? Okay, example 2, the top of the next page, or no, check. Says, use the graph of the related function to solve x squared plus 5x plus 6 equals 0 by graphing. They want us to do it by graphing. Question, if I were to solve this by factoring, can you think of two values that multiply to give you 6 and add to give you 5? 2 and 3. Well, if I were to write those, it would be x minus 2 times x plus 2 and x plus 3. No, wait. x minus 2. It would be minus. X minus 2 and x minus 3. No? X squared negative, it's plus. Sorry. Jeez. Restroom? Water. What's the time? 45. What time is it? 35? Can't go the last 10 minutes. I'm sorry. All right, so A is equal to, what's my A value? We are going to set it up by the graph, but this is how you could also figure it out by factoring. What is the A value of this standard general form right here? 1. So A is equal to 1. What's my B value? 5 right here. What's my C value? 6. Axis of symmetry. How do I find the axis of symmetry when I have general form? Isn't there some little formula or something?
X equals minus B all over C.
Yeah, but you didn't sing it. X equals opposite of B all over 2A. Okay. So X is equal to, if B is 5, the opposite of that is going to be negative 5. All divided by 2 times my A value of 1. So X is negative 5 divided by 2. X is equal to negative 2.5. Ew. Yes, I told you it didn't have to be a whole number all the time. So my answer for axis of symmetry, negative 2.5, is that correct? Technically, no. You need X equals. Where the heck is negative 2.5, Miss Thede? Between what two values? Not 2 and 3. Negative 2 and negative 3. So find where X is negative 2. Right there. Here's X is negative 3. So negative 2.5 is going to be a line in between those lines. Okay, so axis of symmetry, X is negative 2.5. So my vertex I can always find on the axis of symmetry. What's my X value?
Negative 2.5.
Negative 2.5. How do I find my Y value?
Looking if it's above the X axis or below the X.
No, not quite. You have the X value. How can we find Y? You need to substitute that back into the original equation and put that number and value in for every time you see X. So I'm going to do this up at the top here. I'm going to say the function when X is negative 2.5 is negative 2.5 squared plus 5 times negative 2.5 plus 6. So negative 2.5 squared, put the parentheses around it. And does somebody have an answer for me? Say it again. I don't think so. So parentheses negative 2.5 and parentheses squared. I think it should be 6.25. Yeah. Are you getting that now, maybe? Okay. And then we have 5 times negative 2.5. Negative 12.5. And then we have plus 6. Now, I made the mistake earlier and I said, oh, well, that all zeroes out. Add those together for me carefully and tell me what we get. So 6.25 minus 12.5 plus 6. We get what? Negative 0.25. What does that mean? It is just below 0. So negative 0.25. 5. That's your vertex. So the whole line would be -1. This is just below it. Okay? So vertex, your vertex always goes in the middle. So I'm going to put -2.5 here. And its y-coordinate -0.25 here. Now, I don't want to add 1 to -2.5. So what is the next lower integer from -2.5? What's the next lowest one? In other words, -2.5 is between -2 and 3, right? So let's go, this is -3, and go one more past that is -4, and then we're going to make this a -2 and a -1. And we could do a 0 here too, just for kicks. Okay? All right, so let's do -2 squared. -2 squared. So the function of -2 is going to be -2 squared plus 5 times -2 plus 6. -2 squared is how much? Gentlemen? -2 squared. Come on, guys. 4? Just say yes, it's quicker. And 5 times -2 is -10 plus 6. 4 minus 10 is -6. -6 plus 6 is 0. Which one? Oh, I did that for -2. I better put that in for -2. So what do we think -3 should be? Also should be 0 because we're talking about a parabola. So now let's do it for the function of -1. Running out of space. Function of -1 is -1 squared plus 5 times -1 plus 6. -1 squared is 1 minus 5 is -4. -4 plus 6 is 2. So that should be a 2 and that should be a 2. So let's graph these points. -3, 0 is this spot right here, which we were talking about, what are the two integers on either side of the AOS, and it would be right here. And then finally I have -4, 2, -4, 2, and -1, 2. So those are my 5 points. They're going to go up. Okay? So the x-intercepts are what here? They are where they cross the x-axis. That's right here. -3, 0, and -2. So -2 and -3. So my solutions are going to be -2 and -3. Okay. We didn't get quite as far as I had hoped, but I do have homework to start to give you. This is not due until Wednesday. Not due until Wednesday. So let's keep up with the homework. You guys did a much better job keeping up with the homework, I feel, in this last section. Remember, you have 1 week to get me any and all homework, spell work, anything from the last chapter. Okay? This is due on Wednesday. And I did record this, and I probably will be uploading the notes later today. So today wasn't too bad, right? Yeah. Again, x-intercept solutions, where it crosses the x-axis. You can do this. Just get started on the homework. You guys need to come in with questions.